right, a lesson 11.2 is part of, it's 11.2a. I just didn't put the A on here. You're gonna get one that says B tomorrow on it. A lesson 11.2a is I took apart a lesson 11.2 into two different sections. There's like one that builds on it, but one just had a lot of new definitions and stuff on it, and it's all about arcs. So we're really gonna be talking about the arcs of circles. So a new term, but some other terminology that kind of makes a lot of sense that you need to know. Now, these are not fill in the blank, but these are ones you're supposed to have memorized, all right? So I would highlight them, star, do something like that. That would make a lot of sense on there. So with this first one, we're gonna talk about a central angle. Guys, when did we talk about a central angle before? What type of shape did we work with? A polygon. And when did we have, let's just even do that real quick. And everyone knows, what was my favorite polygon that we used for that? A hexagon. When did I have a central angle? When I drew in the central angle triangle, right? And we talked about how it came from the center of that polygon. Well, think about it for a moment. Where the central angle of a circle is going to be. Its vertex is on the center of the circle. Now, go back again to that hexagon for a moment. You guys don't need to write this down, but you can just follow along. Remember, can I circumscribe that hexagon? It's supposed to be with a circle like this. Think about this for a moment. That central angle of that hexagon is also the central angle of my what? Circle. It was the same thing. That's why they use the term central angles, because how I can show the relationship with the circle and with the polygon central angle. So that's why they use those terms in both cases. But here's also the other thing. Let's common sense this for a moment. If the vertex is on the center, why not call it central angle? So here's the key thing in math, especially this chapter. You have to know where the vertex of your angle is located. So when I say central angle, you automatically just go, oh, it's at the center. Big deal. So when you name it, like here in this diagram, it says central angle ABC, the center point of your circle always has to be the vertex, that's the center vertex, right, of the name of our circle. So again, angles of this are still going to be in degrees. Are you guys with me on that? All right, then we also have the term that we want to remember. It's called an arc. Now, an arc, I'm not talking about A-R-K, okay? We're not talking about Noah here. We're talking about literally just a portion of a circle. So when you take about, it's like taking a ring, and if you decide to cut a piece out of it, that piece is the arc. It has a beginning and it has an end. Now, honestly, when I mark that, I mark the smaller arc in blue there. Look at the lovely notation here to the right. Look what symbol I use. An arc. Earth-shattering, isn't it? So really, I name this like a line segment. I have to name it by its endpoints, where it starts and stops. Now, the number of points that I use will tell me what type of arc that I'm using most of the time, but you have to name an arc by its endpoints, no matter what. And then we'll use an arc symbol. Are you guys with me with this so far? Okay, now, honestly, I only marked one arc. How many arcs are really marked in this circle? Isn't there a big arc as well? Isn't this also an arc, guys? You have any 2 points on a circle are going to form 2 arcs. So the fact is, just because I marked the smaller one does not mean that the bigger one's not an arc. I can't name the bigger one because I don't have enough points, but it's still there. All right, so I want you to understand how we name it. It's going to be really, really huge, and we're going to talk about this. All right, a couple other things that's common sense we need to remember. When I look at a circle, how many degrees is that? 360 degrees. And remember, we'd even sit there and say, how many degrees around a point? We would say 360. There's a reason why we talk about angles being 360 degrees. All right, circles being 360 degrees. Now think about it. How do we measure angles? In what? Degrees. Guys, where is my protractor? Actually, we'll use this protractor. Look at a protractor. Is it shaped as a semicircle, half a circle? It's in degrees. How do we ever measure angles? In degrees. So there's a reason why we talk about degrees of circles. They're actually the relationship between a central angle and this. So when I look at this arc right here, let's say that was 40 degrees, what would you tell me the measure of that angle would be? What do you guys think? It would be exactly the same thing. That's how you've measured them. We never would sit there. If you were a kid and I said, okay, really your protractor is just half of a circle and a circle is 360 degrees, your angle is a portion of the circle. Wouldn't that confuse the world out of you? Think about it now. Now it's kind of common sense. Yeah, it's 360 degrees. Now that means this arc from here to here is going to be 40 degrees as well. The angle is 40 degrees. So they have what's called degree measure. Now arcs can also have physical length, not just degree measure, but we'll use those to help us. Are you guys with me a little bit more on this? All right, so we have 3 different types of arcs that we have to work with. We have what's called a minor arc. Now this has, all right, this is the complicated definition that I'm going to give you Gregerson's shortcut one, okay? It says an arc whose points are on or in the interior of a central angle. Okay, here's the easy measure. Are you ready for the best one? Its measure is less than 180 degrees. It's an arc whose measure is less than 180. Now, looking at this diagram to the right, or actually let's go in the middle here, it says the measure of a minor arc is equal to the measure of its central angle. So basically, it's like what we just did up above. If this angle is 40 degrees, what's the measure of that arc? 40 degrees. So notice notation. Notation, I put a what in front of my arc? M. Isn't that the same thing we do for angles? Degree measure. Oh, look, the relationship of the two comes through with flying colors. So if I'm looking for the measure of this minor arc, arc AC, then I just have to know the measure of angle ABC. So if that's X degrees, guess what that one's going to be? X degrees. Now here's the other thing. Look how many points did I use to name that minor arc? 2. You can use up to 3, but if you see an arc named with just 2 points, it's going to be a minor arc. It has to be a minor arc for notation wise. So if it's named with only 2 points, it's a minor arc. So that way, if I say arc AC, I'm not going this direction. That is too big because it's only named with 2 points. If it's named with 2 points, I know we're talking about the little arc, the minor one. Think about it. When you're in the minors, do you get paid less than if you're in the majors? Any sport, right? So think about it the same way. If you're in the minors, less pay, smaller angle, smaller arc. I know it's goofy, but it's an easy way of memorizing it, okay? Now, keeping with that analogy, what's the next type of arc we're going to work with? A major arc. A major arc is an arc whose points are on or in the exterior of a central angle. Let me put it this way. I'm going to highlight real quick. It's the big one, all right? It's going to be going like this. Notice how it's named over here. How many points did I have to use? I had to use 3. Notice which the first and the last points are. They're the stop, the end points, the beginning and the end. Doesn't matter which one you start with, which one you go next, because here's how cool this is. If I start with A right here, I start at A, I go to which one? I end at C. It's connect the points, even around a circle. All right, now what's the easy way of memorizing this? And I think this is the easier one. How about its measure is greater than 180 degrees? To me, that's an easier way of deciding what a major arc is. It has to be greater than 180. So here, one way that you could easily do that is if you know the minor arc's measurement, could I subtract it from 360 and get the major arc's measurement? Yeah, it's an easy way of doing that. All right, the last but not least, one that you need to have is called a semicircle. Actually, I'm going to change colors on that. I'm going to make that one green. When you hear the word semicircle, what does it say to you? Half a circle. All right, so what's its measurement going to be? There's your 180, that's equal, okay? So your measure is equal to 180 degrees. Now, again, notice notation right here. How many points do you need in order to name a semicircle? How many do you see there in that arc? 3. I have an endpoint, which is going to be the endpoints of my diameter, right? So I have the 2 endpoints, and then I have to have a point either above or below. So like here, if I use F, that's going to be the semicircle on top. If I had a point down here, let's just say like H, I'd go, ooh, EHG. I'd have to be very specific. So you need 3 points. Are you guys with me on that? All right, and if you don't know the measure of a semicircle, I'm greatly concerned. Okay, it's 180. You've used that terminology many times in your life already. All right, a few things you need to know. Minor arcs may be named by 2 or 3 points. It is most common to be named by 2. But if they do 3, it's because there's a lot of points and it just helps you signify where it's at. Major arcs and semicircles must be named by 3 points. All right, the end points are at the end. The middle point is just somewhere to let you know which direction to go. Play connect the points when you do that. All right, now some other terms that we need to know. This makes sense. Guys, what does adjacent mean again? Remember when I had adjacent angles, which we use all the time now, that we have a common vertex and a common side, right, and they're coplanar? Well, we're going to have adjacent arcs. Adjacent arcs are arcs of the same circle that intersect in exactly 1 point. And this notation turned out really bad, so there should be arc symbols above this, but I don't know if you guys can fit them in there or not. So I'm going to do it down here. Arc RS and arc ST are adjacent arcs. Correct? They share a common one. That's common endpoint. They have a common point. They just don't overlap each other. Just think about adjacent arcs can't overlap. Just like adjacent angles, could they overlap each other? No. So the same type of a scenario here. Now, why is that so important? So we can actually do math. That's just so we can talk about measurements and do math with it. And it's amazing. Listen to the name of this. I bet you guys will all not be shocked. Ready? Arc addition postulate. Anytime we do an addition postulate, what phrase do I use with you guys? Yeah, basically, this is just that. Sum of the parts equal the whole. Now look what they're saying here. They're saying, okay, arc AB plus arc BC add up to arc ABC. So the 2 smaller ones add up to the bigger one. Common sense, anyone? Could I use the fact that all the arcs of a circle all the way around should add up to 360 maybe? Yeah, all those type of things are really, really helpful. All right, last thing on here. Some common sense stuff. Now here's where this is a definition you probably want to know. Within a circle or congruent circles. I will say congruency. It's easier to do it that way. Just use symbol. Congruent circles. Congruent arcs are 2 arcs that have the same measure. So in this figure, arc ST is congruent to arc UV. Why? Well, they're from the same circle. They have the same degrees. The central angles have the same degrees. What do the arcs have to have? Now, let's talk about common sense with this a little bit. All right, everyone just face back here. No, I probably should do it on the video. I'd rather go on the whiteboard, but let's do it on the video. All right, I'm gonna have 2 circles here. Central angle here, central angle here. All right, do you agree with me? I'd have a minor arc. Oh, I wanted 1 minor arc there, 1 minor arc here. Guys, what's the degree measure of both of those arcs? Are they the same size? Are you seeing why they have to come from the same circle now? Yeah, obviously the one on the right would be bigger. They both have 90-degree measures, so we can both say they're 90 degrees, but are they physically congruent to each other? No, they're not the same size. Degree measure, yes. physical length? No. That's why they have to come from congruent circles or the same circle. Make sense? All right, let's have some fun. A lot of it's just identifying today. So do you think I'm going to care about your notation? You bet. You know I will. All right, so let's do some notation with this stuff. All right, identifying from circle O to the right. I need 2 minor arcs. Who's got 2 minor arcs for me on this one? All right, so arc FE and arc ED. And remember, if I use 2, I'm signifying that's going to be a measure less than 180 degrees. And those were 2 very good, obvious ones. Obviously, could I have picked a lot of others? How about arc BF? Would that be okay? Yeah, arc BF would be 2. Even though it has a measure over 90 degrees, is it still going to be a minor arc because it's less than 180? Are you guys with me? Knowing the definition makes a big difference on this one. All right, I need 2 major arcs. Who's got 2 major arcs they're going to give me? Yeah, Elizabeth. You said which one?
Well,
remember, you have to name 3 points.
oh, right. Arc F, D, B.
Yeah, perfect. You wanted to start at F, go to D, and then end where? End at B, right? So yeah, F, D, B. That's the biggest thing that's hard to switch over when you talk about major arcs, is making sure you include 3 points. You always end and start at endpoints, right? So nothing really new there. It's just that other point in the middle I have to do. Great. Guys, give me another major arc. Who's got another major arc for me? Danny.
Arc C, E, B.
You said C, E, B, so she started C, she goes to E, she ends where, guys? At B. Awesome. So C, E, B. All right, guys, a couple of you are also telling me, so who had different ones than that? Anyone have a different one? Sophie.
Arc D, E, B.
Yeah, she did D, E, B. Guys, do you agree with her? All right, anyone else have a different arc? Anyone do like C, B, D? Can I do C, B, D? Do you see how there's a lot of options? As long as you're over 180 degrees, are you good? Awesome. All right, I need a semicircle. What's going to be the clue that I have a semicircle? If I have what drawn in? As long as I have a diameter drawn in, your life is simple, people. Simple. Because what's your endpoint of your diameter? Just give me some endpoints of a diameter, my friends. Yeah, BE. All right, so I'm going to go B and E. I just need a point in the middle. All right, so you do F. So we're going to do the top one. What would be another one that I could do? Yeah, FDC, would that also work, guys? Because don't I have FC is also a diameter? Are you seeing how you have some flexibility here? It's not hard to identify them. All right, next one. I need a pair of adjacent arcs. Adjacent arcs. Help me out, people. What do we got for adjacent arcs? All right, you said BF and FE? Mm-hmm. BF and FE. Yep. They're right next to each other. Pretty simple? Yeah, I agree. I need an acute central angle. An acute central angle. Means that's a measure less than what? 90, okay? So give me one that measures less than 90. Angle what? Lydia.
Angle EOD.
Yeah, EOD, awesome. Could I have like angle, probably FOE would be another easy one to do, or angle BOC would probably be the ones I would have picked, either of those. All right, I need a pair of congruent angles. A pair of congruent angles on this one. That is meant to be as easy as it looks. Meant to be as easy as it looks. All right, I want someone new to answer this one for me. Come on, guys. Take a risk. Helena.
Angle BOC and angle FOE.
Yep. They're congruent to each other because vertical angles, right? My 2 diameters are intersecting. Do you think vertical angles are going to come in handy in this chapter? What do you guys think? Oh, yeah. Think about all the diameters you're going to have intersecting. Total help with the measure of things. All right, so now on this stuff, we're going to go fairly quickly through this. But guys, I need you to have your calculators out because we're going to make it pretty easy. One of the most common reasons why we have to know arcs is because they like to display data in pie charts. And in a pie chart, how many degrees around is it supposed to be? But how many, what's your percent you're supposed to worry about? 100. So when you work with this, they want to find the measure of arcs and angles based off of your pie chart. So we're going to have to convert percentages to angle measure, is basically what we're doing. So on this first one, for instance, I'm looking for the measure of angle. And we're going to go, let's use the red here, of angle FMC. So I'm looking for this angle right here. Well, what do I have to do? Don't I have to add up all three of those little pie pieces, right? What percentages do I get? I get 9%, right? 9% plus 10% plus 11%, which gives me how many percent? 30%. So from here to here, it's 30% of my circle. Well, I want to know the degree measure of that. How do I convert that? Well, don't I go just 0.30 times what? 360. So we're just taking what fraction of that we have. So 0.3 times 360. Someone do that real quick for me on their calculator. Should be 108 degrees. Make sure, remember, we're converting it to degrees. If you need to, put like degrees there, so remember we're working with angle measurement. Does that make sense? All right. Now, I'm looking for the measure of, here's the next one. Let's see if we can do it. I'm going to use a different color here. Angle arc AHB. So I want to go from the green one here. Guys, what's the easiest way of solving for the area of this one? First of all, is that a major or minor arc? It's a major arc, correct? Now, I could take the time and add all of those up, correct? Or can I go a faster way? What's the faster way? Yeah, subtract 125 from 100, right, and get what percent? 75%. So I know this whole angle from here to here is 75%. So can I take 75% of 360, right? So here I'm going to go 0.75 times 360. What should you guys get on that one? Should be 270 degrees. What do you guys think? You've done those before. It's just now you actually have the right terminology for it. Yes.
When it says like the measure of the arc, does that always mean the degree? So like
When it puts an M in front of it, yes. It's going to be the degree measurement. And that's why it's so closely related to angles. So the M in front means measure. I physically have to ask you for the length of the arc if I want the length. All right, next one. It says find the measure of angle CFD and the measure of arc BD. So I want the measure of angle CFD right here. Suggestions, anyone? Don't forget things you already know. Do I even have to use the circle right now? What do I know about segment AC? It's a diameter, right? Guys, what can I do? Yeah, can I go 180 minus what? Yep, 974 plus 52. All right, someone do that real quick on their calculators for me. What do you guys get? Did you get 30.6 degrees? I know, I make sure it's degrees if I'm talking about the measurement angle or the degree measure of an arc. All right, so we know that's going to be 30.6. Awesome. Now, I'm looking for the measure of arc BD. All right, if I just use 2 points, is that a major or minor arc? So it's a minor arc. So that means we know, let's go here. We know I'm looking for this arc, not the big one. All right, suggestions on how I possibly could solve for the measure of arc BD. What do you guys think?
Yeah, C is vertical to the FE, so you'll get C is just the percent multiplied and you said CFE and multiply that by percent.
Okay, that would be great, but that's a lot of work. I was gonna think easier than that. Do I know if BE is a diameter? Is the measure of this angle, is that going to be the same as the degree measure of my arc? Right? If this is 52, what's left for this angle? So could I go 180 minus 52 and get 128 degrees? That means this whole angle is 128. Which means my arc is what?
Oh, I was
No, actually, you could have done it the way you're thinking. Now, guys, could I go ahead and use that idea? Because I know I've got my 97.4. Could I still add my 30.6 to it? Could I use some of the parts equal the whole to get that one? I mean, there's more than one way you're going to get 128 degrees. I just like trying to use it so the numbers are nice as quick as possible. All right, did everyone see how to get that one, though? All right, so let's look at the next one. On this one, I want to know the measure of arc JKL, and I want to know the measure of arc JLN. Now, be careful. JKL, is that going to be a major arc? Not in this case. This is where the minor arc can go either way. They're just being very specific, so you know exactly which one they're looking for. So see, minor arcs are kind of iffy if you're going to do just 2 points or 3. So, guys, how would you do that one? Well, yeah, I'm going to use the fact that the angle and the arc are the same. So literally, you could even say it like this. I know arc LM is 40. I know the bigger arc JLM is a semicircle. So I could just go 180 minus 40 and get how many degrees? All right, I got to pause here for a moment. Does everyone see how closely I'm relating the angles and the arc measures to each other? Are you guys with me on that? Another way you could have done that is the fact that I have a linear pair that's 140. So that makes that 140. But you have to be really, really good at marking up your stuff if you do that. All right, let's look at another one. I want the measure of angle JLN. So this time I'm going, arc JLN. I keep saying angle instead of arc today. Have you noticed that? Really not helpful on this. All right, so JLN. All right, is that a minor, major, or semicircle, first of all? Major arc. All right, how are you guys going to get it? What you guys said? I heard answers, but not loud enough to work with. Yep, I go 180 plus 25 on this one. Because from here to here, do you guys agree with me, is 180 degrees because it's a semicircle. And then I can add just that small arc on. So with that, it's going to be 205 degrees. Guys, what am I doing to my diagram? What would be a good idea for you? Mark it up. Excellent. And here's the other thing you could do. You could go through and put all the angle measurements in, and then or all the arc measurements in, and just go that way as well. Okay, now I cut this from an old set of notes here, but here's the one thing that's going to drive me nuts, so everyone fix it now. Now I can go, oh, okay. Because if I'm going to find the measure of each arc, I'm going to use correct notation. One has to go in front of each one. An M, right? Now on this, I would also suggest this idea. I would put in everything you know for angles and arcs before you ever start answering a whole bunch of these. Like for instance, guys, what's the measure of angle ECD? If that's 50, isn't this 50? This one's 130, right? What about arc AB? What's the measure of arc AB? 90. What's arc AE? Now can I quickly get everything I need? This is where I'm going to use the sum of the parts equal the whole, the arc addition, to help me out. All right, guys, what's the measure of arc AE? It's going to be 90 degrees. And that's because angle ACE is 90 degrees. Central angles and their minor arcs are going to be the same. All right, arc ED. What'd you guys get? 50. And I'm just going to remind you what we did there, right? So 180 minus 130 is 50, but we had 50 degrees. What's the measure of angle DBA? If I'm going DBA, what do you get, guys? Can I use some of the parts equal whole? 90 plus 130, which equals 220 degrees. All right, how about the measure of arc AED? $140, right? So I got 90 plus 50 equals 140. How about the measure of arc ABD? It should be what? Notice, I was trying to fool you, but you shouldn't have been fooled. Are those the same arc? Yeah, these two are exactly the same. It's just how you chose to name it. Which one you started with, you ended up was different, but it's exact same arc. All right, arc BD, 130. Now, guys, stop for a moment and listen to me on here. You will have harder problems than this on your homework. And one of those is you're gonna have to apply some algebra. But can we use some stuff that we know? Can we do like the sum of the parts equal the whole? What's the degree measure all the way around a circle? What do I know about the measure of linear pairs? What do they add up to? So all that stuff is still gonna be used even algebraically. So taking these basic concepts, you guys should be okay. All right, you have homework supplement again, as well as bookwork. Are you guys good with that?
Yes.
All right.